Hi there, have you ever heard about the Marangoni effect? Well, let me introduce myself. My name is Carolina Valdivia and I'm going to explain it to you.
Imagine you decide to have a cup of tea. Everything goes as normal as always, except for one detail. The mix of herbs that you just poured into your cup is going upstream to the flow of water.
Probably you think you're hallucinating, but nope. Your mind isn't playing tricks with you, and actually, it has a scientific explanation.
But first, we need to put in context some concepts so we can understand what is going on. Starting with the surface tension, known as the property of the surface of a liquid that allows it to resist an external force. This is a property that allows small insects to walk on water, or the needles to float in it. It can also be manipulated by surfactants, which are substances that decrease the surface tension, such as soaps and detergents.
But what does the surface tension have to do with the Marangoni effect?
Well, the Marangoni effect consists on the mass transfer at the interface between two phases due to a gradient of surface tension. We can observe this by putting together in the same container alcohol and water, which have different surface tension. Adding drops of colorant to the water is going to make visible the mass transfer. Here is another example of it. The direction of the gradient of surface tension to the interface can be altered by change due to variations in solute and surfactant concentration, and temperature variations along the interface, which depending on the fluid can produce a strong convective motion.
But what happens when the upstream flow is occurring? The mix of herbs acts as light particles that float on the surface, not being heavy enough to break it but to decrease it. When you are pouring water into the cup of tea, the surface tension will try to reach an equilibrium between the highest and the lowest in this interface, causing that the flow take with it the light particles and contaminating the other phase. Marangoni effect is something that needs to be considered in many industry processes, such as welding, crystal growth in semiconductors, and electron beam melting. It principally affects the melting process of the materials, where the large thermal gradients can generate Marangoni effect forces within the melt, potentially negatively affecting the quality of the materials, causing deformation or inhibiting semiconducting capabilities, resulting in defects within the device. But it is also the cause of something that most of the scientific community should be aware of: the upstream contamination that may occur in practical applications such as the discharge of a standard pipette or the simulated release of waste into larger scale channels. Nevertheless, understanding the circumstances under this phenomenon works is still an actual problem, since it is affected by the dynamics of swirling fluids that remain to be fully investigated, meaning it could imply that some of the industry and laboratory procedures need revision.